All right, I'm Vikram. I work in the Angular team at Google. I've been in the Angular team for around 3 years. This is the first time I'm ever talking in a conference in India, so I'm really excited about that. And today I want to present an overview of Ivy, which is the new rendering engine for Angular. And I think, all right. How many of you have heard of Ivy before? All right, so quite a few number of you. So I have few goals for the talk. I wanted to. I was thinking of how to convey like what you would get out of Ivy. That is the main goal of the talk. So why do we want people to move to this new rendering engine? That is the main point I want people to take out of this talk, essentially. And if you're deciding things like, hey, do we upgrade to the next version of Angular? Do we use the Ivy rendering engine in your organization? This talk, I essentially want you to go back thinking, yes, we want to try Ivy as soon as possible, right? The next part of it is more going into the technical details of how Ivy works and how it translates to the benefits that we talk about in the first part of the talk. And hopefully nobody sleeps and like you're engaged and I'm not too boring, and so that's my other goal for the talk. So, at the end of the talk I'll be asking some questions just to make sure like you guys have been listening, kind of thing. So, so just to go over some terminology, the current rendering engine in Angular is called the View engine. I don't know whether you have heard of the term before. And the new renderer that we are working on for Angular is called Ivy. These are just names. Don't ask. They don't mean anything. So. And so in the presentation, whenever I say View engine, I'm talking about the existing Angular renderer, and Ivy is the newer one. So let's get into why Angular team started working on Ivy and why we want you to start using it, right? One of the trends that we are seeing and like everybody's aware of is, and Jason also mentioned in his talk, like mobile web usage is something that's going up all across the world. And if you take a place like India, like one of the statistics I found on the web essentially says like out of the people accessing internet in India, 96% of them would be accessing it through their mobile device, right, by 2022. And so what does it mean from the Angular framework's point of view, and why are we doing like a big change, right? I just want to go over like what is the costliest resource that you have in your web app or web page today. Like, is it HTML, is it CSS, or is it JavaScript? What do you guys think? JavaScript, so cool. Yeah, it's JavaScript. So it has the same overhead as the other resources. You have to download it, but it has the extra overhead of actually parsing and executing the JavaScript, right? So byte for byte, JavaScript is so much more costlier than any other resource in your web page. And maybe images come right after that, but still JavaScript is something we control from the framework point of view, and something we want to reduce, right? So the main motivation for Ivy is to reduce your production JavaScript bundle size as much as possible, right? So what can you expect from like JavaScript bundle size perspective, like in the shorter term, right? Ivy is not going to be like a one shot, I just switched to Ivy and everything is brilliant kind of thing. We want to like phase it out in few releases. And so what can you expect in the shorter term, right? I think from our most recent experiments, I think the thing that you can expect immediately as soon as you switch to Ivy is the JavaScript size that comes from each one of your templates is going to drastically reduce. These are made up numbers. Don't quote exact numbers. This is just an example application, or just an example of what kind of savings you would see initially, right? So if you think of your application as being made up of JavaScript coming from Angular framework itself, which is dependent on how many features of Angular you use, right? And then if you have the JavaScript generated from your Angular templates, your HTML templates, right? If you think of your application of being made of those two, so light blue being the Angular, dark blue being your templates, what you can immediately see switching to Ivy is, even though you are still using the same features of Angular, and since it's working in a backwards compatible mode, you wouldn't see an immediate reduce in Angular framework size itself, but what you would immediately see is for the generated code for the templates, it's almost like 1/4 or 1/5 the size. So, okay, so this is the main selling point for Ivy, right? So if you want to have the bundle sizes small, working really well, first load user experience to be really fast on mobile devices, slow connections, but you might still be like, I'm just developing an enterprise app, working on a desktop. Like, what does Ivy provide? Ivy provides more than just the JS size savings. So the other advantages of Ivy is the code becomes much easier to debug. This is especially with the generated code. When you see the Vue engine generated code today, it might be difficult for you to step into when different elements are being created in the page and stuff like that. This becomes much easier. I'd go over the actual technical details of it later. The other major advantage of switching to Ivy is faster compilation. This again comes due to the locality of compilation in Ivy mode. Again, I will explain when I come to that in the technical part of it, but essentially each component or directive now works through a cleaner public API, so that if you change component A, all you have to recompile is component A and not all of its dependencies in your project, right? So it makes for much faster incremental compilation, and if you think of if you're using Angular material, currently your compilation compiles Angular material first and then your project, so the compilation speed is much slower. With Ivy, what it will allow you to do is Angular material will come pre-compiled in NPM that you don't have to recompile every time in your project, right? So that's, again, if you're not just interested in the bundle size, I think faster compilation is something definitely everybody in this room would benefit from. And if you are shipping libraries, again, it makes it much easier to ship code that is directly consumed by your users. And faster test execution. And there are other things which Ivy sets up for in the future. Like currently, if you're thinking of doing something like dynamic component loading, the APIs are a little difficult to use. It's confusing. What's a factory? And then there's a component factory resolver, and you have to do template ref and things like that. With Ivy, these things become much simpler. It almost like you import the component and you render the component and you're done, right? So if you have dynamic imports, all you do is just import the component and render it. So Angular Ivy, we expect it to be available in version 8, which is coming out, which is the next version of Angular, I guess in April. I'm not sure of the schedule. It'll be opt-in. It means that by default, you would not be in Ivy mode. You would have to essentially switch a flag, which puts your project in Ivy mode, right? And we have built Ivy in such a way that it's backwards compatible, and this has been one of the important goals of Ivy from day one. This is so that you don't have to spend too much time migrating. There will still be some corner cases where you would have to fix things in your project. But what we are doing right now is rolling out Ivy-based Angular inside Google, where we have hundreds of Angular projects already using Angular, and we are switching them to Ivy mode so that we can learn more about what it would mean for you users to essentially do the same switch, right? So we would have like a white paper or a guide to specifically say, okay, if you're using this pattern, maybe it's not going to work out of the box with Ivy, and these are the changes you have to do. And again, we are also looking at automating those fixes as much as possible with the same kind of experience you had with upgrading RxJS in version 6. Like wherever possible, we are also looking for like opportunities to automate through the CLI and tools. So. All right, cool. So is everybody convinced that you have to switch to Ivy? Yes. Yeah. All right, cool. So that's good. So that I want to be the main takeaway of this talk. I'm going to go through some of the technical details of what Ivy entails, right? So how does all of this work, right? What are the changes, and why are things smaller, and like why are we doing this year-long effort to switch the rendering engine, right? So I'll briefly go over the architecture of Ivy. So one of the main concepts is essentially now when you compile a template, previously with the view engine, so this is the current model, you can think of the component.ts is your main component code, right? And it will reference external templates, external CSS, right? And when the Angular compiler runs on it, it produces the JavaScript code for your component TypeScript itself, but it also produces this extra thing called ngFactory, right? Which has the representation of your template compiled into JavaScript and essentially stored there. With Ivy, we no longer have two separate outputs for every compilation. We just have a single component.js. And this simplifies a lot of things, and we'll go through like what those are. So what happened to all those information that was there in the ngFactory? Like where does that reside now, right? Whenever the Angular compiler sees the Angular specific annotations like component, directive, injectable, ng module, it creates an extra static field in your compiled like component.js. If, for example, if your component code looks approximately like this, you have an @component annotation. It has an inline template. Root comp is a component.ts, right? This is the component.ts. And component.js, the export class root component part is essentially the same as before. It is just a JavaScript compilation of your component, right? Nothing changes there. What is extra is the new ng component def static field that gets added to the compiled component code. And this has all the metadata related to your component, right? So this was previously in ngFactory. Now it's essentially as part of your component.js itself. So this is just showing what part gets translated to what. And the part I want to highlight here is the root comp underscore template. It's essentially the reference to, so if you see here, this is just the metadata. The actual div, span, child comp information itself is not here. It's essentially in the root component template function that gets generated. And that now is, you can think of as an executable representation of how to create and update your template. So we had this template in the example, and if we expand like what the template function would actually look like, it would essentially just be a series of instructions like this, right? You can think of it as like a microcode to an interpreter, where these are the instructions to the interpreter asking it to create elements, add a text field, and things like that. Is it clear so far? All right. So what are the benefits of moving to such a model, right? We saw this, the size savings and faster compilation. How does this, what I explained right now, translate to all of those things, right? So we'll look into 3 of the things that I mentioned. So bundle size, faster compilation, and flexibility. So for bundle size, the main idea for Ivy is you don't have to pay for features of Angular you don't use. That's a big change from how it works before. And the framework itself is now tree shakeable. So let's say you are writing a simple component that you want to share with different parts of your company. Like if you just wanted to write that one element and share, and it uses a smaller subset of Angular, you don't have to pay the cost of the whole framework anymore with Ivy. So let's compare it with how things looked in View Engine and how it's with Ivy, and see like where the actual difference is, right? So this is a similar output from how View Engine translated your templates. The main concept of View Engine is when it looks at your template and it doesn't generate like executable code per se, but what it generates is a data structure that represents your template, right? So it's an array of instructions, right? As compared to Ivy, where it was directly executable instructions. So if you look here, so View Engine, the idea is you have a template data structure, and during runtime, Angular takes that data structure and interprets it code by, like opcode by opcode, right? So the first opcode might be, hey, start an element, so it would create an element in the DOM, right? And it might say, hey, create a text subchild and things like that. So, but what happens in this model is you can roughly think of the rendering engine as a huge switch case statement, right? So, and it's an interpreter. It has to have the implementation of all the features of Angular embedded in the switch statement. You can roughly think of it that way, right? The problem with this model is now your code, the framework code itself is not tree shakeable. Do people understand what tree shakeable means? Yes, so cool. So your JavaScript bundler is not able to decide whether a particular branch needs to be in the final production build or not. It's going to assume you need it, right? It can't decide during build time whether you need it or not, so it's going to play it safe and throw it in your production bundle. So there is no way you can pick and choose what features of Angular you actually need in the production bundle. So. And then we can compare it with how Ivy works. So as I said, Ivy for a template generates instructions as executable functions. So the difference here is if you see roughly the code generated by the template function calls, they are actually direct function calls into the framework, right? Instead of the framework interpreting what was there in the template, we have essentially changed the direction of the dependency, right? So now you have element start, which is a function that is exported from Angular, and now the bundler is able to clearly see the relationship between the features used by the template and the implementation in the framework, right? So the bundler is able to clearly create a relationship between your template and the function. So now it knows you use only element start, text, and element end. There is no need to bundle and carry all the unused Angular features in your final bundle. So this is like the major change, and this is how like we expect like people to be saving bundles. As I said, in the shorter term, since backwards compatibility is our main goal, running in backwards compatibility mode, and we expect like at the end of the day when your templates use different features of Angular, it's going to roughly end up being the same for now, but we think it sets up the foundation for us to do a lot more later. So Ivy itself is written in a way that it can tree shake things that you think it's core part of framework. So like if you actually don't end up using dependency injection, Ivy can actually remove it, right? So the bundler can actually remove all the Angular framework related stuff to dependency injection. So you now get to decide based on the trade-off of how much you want to be your package size on what features you want to pick and choose from Angular. So if you're really like performance sensitive part of the app, you can decide, oh, okay, maybe I don't want to rely on dependency injection to squeeze out the extra bytes you need for that, right? And similarly, ng templates, queries, animation pipes, IETN, and services that are core to the framework itself. Previously, these were, you could not choose what you need, but now it's up to you. And we keep talking about tree shakeable, but I think the other term we should be also using is module splitting. So just to explain what that means is tree shakeable just decides what, you can think of what ends up in your final bundle, right? But module splitting is more about what pieces of Angular itself ends up in which module that you're loading, right? So you can think of, let's say you want to have the first user experience when the user lands on your first page to be really fast, and like you do in Angular, let's say you do code splitting by routes, right? So if your first page uses only 10% of Angular, right, it is now in a position to bring in only 10% of Angular as part of the first page, which was not possible with View Engine, right? So we should not be, I use tree shaking because it's easier to visualize, but what we should be thinking more about is also the module splitting, right? That's where you really see the difference. So now you can see like, okay, my first page, I can decide, okay, I'm going to use only the 10% of Angular, and now you get only 10% of Angular features. So we created a Hello World application just to see how much we can push tree shaking inside Angular. This is more of just like a baseline benchmark. So currently, you know that as soon as you use Angular, you're probably getting like, I don't know, 50K, 60K, 100K of Angular immediately in your application. But with Ivy, what is possible is sizes like 4.5 KB, right? So this is a Hello World where Angular itself is so much smaller. This is compressed and minified. I think the uncompressed size is around 12 KB, right? So this is essentially the main benefit that Ivy provides. The next thing is, of course, faster compilation. Again, this is something that will be useful for everybody. I mean, so we want to be in a world where everybody thinks about bundle size and the initial bundle payload. I think we are not there yet. As a team, we want, even when you're designing enterprise application, to think about performance and JavaScript code size and stuff like that. Ivy sets a foundation, and we want people to think about those things and move towards that. But I understand that all of us are not there yet. So I just want to go into other features of Ivy which would be useful for you right now, right? So faster compilation is definitely the top advantage other than the bundle size. So again, the main change again in Ivy is the way the code is generated by Ivy. Every component now references its child component or directive it uses through a much cleaner public API, right? So if you want to compile or recompile a component when it changes, you need only the local information of that component to do the recompiles. So what that means is previously in the View Engine, you would need much larger input, and you would have to recompile a much larger subset of your app whenever something changes. But now we are in a position to almost work like TypeScript, right? When you're I mean, at the end of the day, Angular compiler is almost like an extension to the TypeScript compiler. So you have input TS, and it produces output JS, right? An Angular compiler is, you can think of it something similar, but TypeScript is very strictly one TS to one JS, right? The current version of Angular is more than that. It has to have information about more of your component TSS to produce more of the component JS, right? So the unit of recompilation was much bigger because it had to have more information about components and their dependencies. But in Ivy, we are moving closer. We are fully not there yet. There are certain corner conditions where it would re-trigger a bigger recompilation. But for 90% of the cases, if a component or directive changes, we have to recompile only that component. So how does Ivy do that? So let me take ngIf directive as an example, and let's consider this generated code in View Engine and Ivy. So in View Engine, just to illustrate the non-locality idea I'm talking about, so this is the same example template we have been using. This is the code generated by the View Engine. So just to highlight the ngIf part, so there's a directive definition instruction in View Engine that gets written, and it references ngIf directive, right, which is fine. But the odd thing here is there is something about view container ref and template ref that is being added to your generated components code. Does anybody know where those two come from? Take a guess. Sorry? Dynamic loading, yeah. Who else said something else? Lazy loading. Okay, so view container ref and template ref are actually things that are injected into the constructor of ngIf itself, right? So if you look at the ngIf code, in its constructor, it actually is injecting these two things, right? But what you don't expect is those two references ending up in the component in which you are actually using ngIf, right? This is the non-locality we are talking about. So even though ngIf, like there is implementation detail of ngIf which is leaking into the usage of ngIf, right? So tomorrow, ngIf is a thing that doesn't change, but you can think of it the same way for any directive you write, right? So tomorrow, if the constructor for ngIf changes, you would have to recompile all components using ngIf, right? So that is the main idea. So locality in Ivy there is no information about what are the constructor parameters for ngIf in your generated code, right? So where do those go, right? They have to go somewhere else. So where they've actually went is, remember I told you about static fields generated for each annotation. So for an injectable annotation, or for, sorry, this is a directive. For a directive annotation, ng directive def is the new static field that is getting generated. And now that information about the constructor and what it needs to be injected is stored in there. So now it's local, right? The ngIf constructor parameters are part of the ngIf.js generated code. So the references are now much local. So if you wanted to recompile when ngIf changes, all you have to recompile now is ngIf. You don't have to recompile the whole world to do it, right? So this is also very useful for library developers, right? So previously we were in a position where you couldn't actually ship the code that was compiled by the AOT compiler as part of your NPM distribution, exactly for the reason I said now, right? Because there could be something that changing or even changing in the version of the compiler, and it affects the generated code, and since things are more tightly coupled, we weren't asking you to actually ship ng factories along with your code. But with Ivy, what becomes possible is since the references are local, and we also have the instructions which we know will always be backwards compatible. You can again think of it as an instruction code for a processor. Like if we are adding new features, we always add it as a new instruction so that existing code always keeps working, right? So if somebody like Ignite UI or Angular Material wants to ship Ivy code, now they would ship fully compiled code, right? So as a user of those libraries, what that means is previously, since we aren't shipping AOT compiled code, every project would have to recompile every component library that it's using, right? But now we are able to ship actual AOT compile code as part of NPM, and when you do ng build, it's building just your app, right? It doesn't have to build the whole world again to get your application running. So you can see how that would really like speed up. So there are two build times, the initial build time and the incremental build time. You can see how it can improve both of them. The third part, I'm not going to go into too much detail, like, but again, it's something to do with not having ng factories generated every time. But essentially, Ivy provides like a flexible foundation for us to do more things that where in other frameworks you would have taken for granted, like dynamically loading components and things like that. While it's very difficult in current Angular where things are more static, and this is again has to do with how the references are put into the generated code. Now each module is a nicely isolated piece that when you want to dynamically load a component, you don't think about factories, component, factory resolver, all the stuff. All you would do is you dynamically import your component.js and just say render component, right? And that's all you would need to do dynamic component loading in Angular. So that unlocks a lot of, again, like lazy loading features that we don't have to be restricted to lazy loading only at the router level. It allows us to build a stack or a framework that essentially allows you to do a lazy loading even at a component level much more easily, right? So you can think of your page being like a tree of components, and again, when you want to save bytes that you are shipping, you need not have to introduce a router every time you have to do that, right? So, I mean, just to give an analogy, like React is doing things like lazy and suspend, so those sort of things become now much more easily implementable in Ivy. So this now lays the foundation for that. So here is the quiz part of the talk. Anybody remember what is the first goal of this talk? Why Ivy? Okay, cool. What is the second goal of the talk? All right, and the third part? I think that everybody remembers, so that's good. So this is my final pitch. Angular Ivy is in version 8. It'll be opt-in, so you would have to flip a particular flag to enable Ivy in your project. We expect it to be backwards compatible, as I said, with some caveats. We are currently testing it with hundreds of Angular projects inside Google so that we know, get a better picture of what it would take for you to do the migration. Yeah, please give it a try. I still don't have the exact instructions on how we would enable Ivy, but that would be available along with the version 8 release. So switching topics a little bit, so that's the end of the Ivy talk. I just want to spend a few more minutes about like Angular in India and how the Angular team views like India and this whole Angular picture. My first introduction. Do people know what the site is? Okay, so do people know that's built using Angular? All right, is it good? It was so horrible before that it's much better now, yes. So, I mean, but all jokes aside, I think like considering the amount of traffic this site actually handles, it's a very impressive site. And do you guys have any other examples of Angular used in like a big public site? Sorry? Netflix? Okay, they use React. Okay. So, yeah. LinkedIn? All right, you guys are telling things I don't. But I mean, I'm talking more about India, like from India's point of view. Like, we worked with IRCTC when they were first moving to Angular, and that was one of our first like engagement with somebody building something really big in India. But what we have been seeing recently is the most amount of traffic to our documentation site is essentially from India, right? And much more than US or anywhere else. So the last 6 months in a row, a lot of people, I hope it's not because Angular is difficult to understand. I'm taking it a more positive spin. Like all of you are using Angular like much more. So, that's all my talk. Thank you. I will be available throughout the conference, and I'd like to really connect with the Indian Angular developer community. Again, as I said, this is the first time I'm coming here for a conference, and I hope this begins like forming connections with all of you here. So thank you.
Thank you very much, Vikram. That was a very enlightening session.